All right, everyone. Sorry about the mix-up this week, but I'll just post the videos of the first few sections. I won't be closing any. So, next one. Anyway, let's get to it. So, 5.1 angles. So the homework problems are pretty chill, pretty straightforward. So let's just go with a quick definition. What is an angle, right? So a measure of an angle is the amount of rotation from the initial side to the terminal side. And we're going to measure that in degrees for now, and then we'll move on to conversions. So if we start here, this initial side, and then we move to the terminal side, then if it's going clockwise, so counterclockwise, for an arrow right there, going counterclockwise, and it's considered to be a positive angle. And if you start here, the positive x-axis, and you go in this direction, that's considered to be a standard position. Okay, now if we start there and go the opposite way, clockwise, then this would be considered to be a negative angle. And angles will usually be written with, at least in most books, angles are represented by Greek letters. Usually, the main one we're going to use is theta, but depending on what we're doing, we might have an alpha, beta, gamma. Pretty sure that's all we're going to use. Theta is usually the general angle. Alpha, beta, gamma, if we have multiple angles we need to represent, use multiple. That's all. Okay. Now, quadrants, the thing you need to know is the first quadrant right here. Both x and y are positive. This is x. So it goes counterclockwise. X-axis and y-axis. If I go over here, x is now negative, y is still positive because I'm on top. Right? Third quadrant is going to be both negative because we're on the bottom and we're on the left. Right? Fourth quadrant, we have negative y but positive x. Okay. So these are just some coordinates. They're going to ask you later, like, okay, what quadrant are you in? Based on your angle. So if your angle ends up over here, that would be quadrant 1. If your angle spins all the way over here, that'd be quadrant 2, etc. Okay. Last thing we're going to need is the conversions. Let me write a quick note for you there. Then we can start doing some homework columns, and we'll move on to 5.2. So converting from degrees to radians. So we want to go from, let's say, I don't know, let's make it up, right? 30 degrees. You have to multiply by pi over 180 degrees. So you put the degrees on the bottom if you want to cancel degrees, right? So this, right, you end up with 30 pi over 180, which reduces, right, to pi over 6. So multiply by this factor here. Okay, you get to degrees to radians. Now, if you want to go from radians to degrees, use the reciprocals, just 180 over pi. Okay. So let's say I'm already at pi 6, and I want to get to 30 degrees, right? Because that's what we converted this guy to. So pi over 6 times, so use this one, 80 over pi, so then the pi should cancel, leaving me with degrees. Gets me to 180 over 6, which will be 30 degrees. That's all you need to know for versions. Use one of these, depending where we're going, okay? Only thing left would be maybe to mention, I think that's all really for now. So let's look at the homework. This is the homework that you should be doing very soon. The 5.11 angles. About 28 questions, but they're not too crazy. So notice on the first one, it says, select the letter. Can maximize this a little. Select the letter that the angle in standard position for negative 495 degrees. Okay, so standard position means that the initial side is on the x. So all of them have that A, B, C. Yeah, they're all on the x. Negative 495, right? That's more than 360. 360 means you go all the way around. So if it was a positive 360, right? Let me get my pen here. If it was a positive 360, you'd go here all the way to here. If it's a negative 360, then you go all the way back to this direction. Okay. Since it's a negative 495, that means that it went all the way around in the negative direction and then a little bit. So all we really need to figure out is how much more is that is this than negative 360. So okay. Negative 360. Let's use positive numbers so we don't confuse ourselves. 495 minus 360. Is that going to be? Let's pull out our calculator. Right? Who cares? That'd be. Let's see. So I don't mess it up. 95 minus 360 and 35. So this is the angle we actually care about. It's negative 130. So an angle that can be represented by a different angle. So negative 495 is the same as negative 135. These are actually considered to be coterminal. So where is negative 135? Well, 180. Negative 180 would be from here to here. So it would have to land somewhere around here, right? So this is negative 80 something because one quadrant is 90 degrees. This is 90, right? Going from here to here is 90. Going from here to here is 180. Going from here to here is 360, right? So keeping that in mind, this has to be negative 135. Starts here and goes that way. None of these others would make sense because this would be negative. I'm going the negative direction. This should be bigger than 180, negative 180. Like this is like 225, negative 225 or something like that. So the only one that makes sense is this guy. Okay. Ready? So let's find out. Let's find out. I think it is F. F. Yeah, it's the only one that makes sense. Now the next one, negative 135, which we just said was the same as negative 495. It's a coterminal angle. It's going to be F again. Okay. All right. For these, let's use our unit circle that I posted in Canvas. Also, I sent it in Remind. Let me go grab that guy real quick. So negative pi over 3. So you can use this on your exams as a separate sheet. Pi over 3 is right there, right? Or 1 pi third, same thing, pi over 3. So negative pi over 3 would be the same as saying negative 60, right? So it'd be going over here. So, let's see here. My pen back up. So positive pi over 3, 60 degrees, starting here. There's my initial side and my terminal side. Negative pi over 3 would be starting here and going all the way over there. So this would be my terminal. So as we can see, this is quadrant 4. So go back to the homework. Right, this is for now. This one would be quadrant 4. 3 pi over 4. 4. 3 pi over 4, well, let's see. 3 pi over 4 is right here, so it's positive, so that means I'm straight to it. That's quadrant 2. They write it with the Roman numerals, but doesn't matter to me. 13 pi 6, that is not on here. That is not a known angle. So what you'd have to do, either convert it to degrees or kind of get an idea, because we know pi is 3.14. So if you punch this into your calculator and you're like, okay, well, it's a little bit above 3.14, a little bit below this, you can kind of figure it out, or just change it to degrees. Okay. So if we were to change that to degrees, let's say 13 pi 6, right? Use this as our first example on paper to make it up. Change 13 pi over 6 into degrees. Then we can answer the question a lot easier as to what quadrant this is in. So multiply by 180 over pi. That cancels, that cancels. We get 13 times 180 over 6. 180 divided by 6. 90. It's fine. There's 13 there. 20 divided by 6, and then times 13. This will be 390 degrees. So I'm going to go back to the homework and say, okay, 13 pi 6 is 390. So that's a lot easier to find, right? So this is the same as saying 390. Okay. So as we said earlier, 360 is a full revolution. So 390 would be a full circle plus 30 degrees, right? So we go all the way around and then 30 more. So the actual coterminal angle, right? So 390 is coterminal, meaning it's the same as 30 degrees. So that's how coterminal means. It's just you have an angle presented by a different angle. If I add another 360, I'll land there again, right? Should be just a different number, but same place. Also, the answer would be quadrant. Quadrant 1 was the answer. Anyway. The next part of the question, do the same thing. Change 5 into degrees, and then you'll anyway, so that's the first two questions. This is the similar stuff here. What quadrant is this in? So whenever your number is bigger than 360, just subtract a few times. So you know what? I know 714 means I made a full revolution. So subtract a full revolution. 714 minus 360. That's 354 degrees, right? Now look at your circle. Said 354, right? Yeah, that's right. 354. So 714 is 360, then 354. So I'm gonna end up right before another full circle, right? So that's gonna be quadrant 4. So you do the same thing with the negative ones. Negative 372, like, okay, well, we know that's multiple 3, that's at least 360 in the negative direction, so all you gotta do, if it's negative and it's large, just add 360s until you're positive. And then you'll know where you are and what quadrant you're in and a coterminal angle. Right, so if I add 360 to negative, 6, 7, that's going to be negative 312. You can kind of figure out, you can already figure where it's at, but you could add another 360 and get the positive coterminal if you want to. That would be 48. So you can either go to 48 or you can go to negative 312. It's the same thing. So look at your circle that I sent you. 48 would be right here, or you can go negative. But either way, the answer would be quadrant. All right, let's look at. So this one makes a lot more sense when you start working on it. It's not too much notes to write. Pi radians. You could do conversion, but I mean, pi is equal to 180 degrees. That's one of the ones you should memorize. But if you were to do the work, right, using the notes I told you, multiply by the conversion factor. Right? That's how you're supposed to do it. These will cancel, leaving you with 180. Now over here, it says find the radian degree of 350. Well, you take 350. Right, let's do that on paper actually. Number 6. Take 350, multiply by your conversion factor. So let me write the question down. Convert to radians. So you take 350, multiply by pi over 180. So then you'll get 350 pi 180. Zeros cancel. I don't think it reduces any further. 35 is what? 7 times 5? 7 does not go on 18, 5 does not go on 18. I think that's it, it's 35 pi. So just make sure you reduce your fractions when you do conversions and then type it. That's all there is to do. Okay. So 5, 6, 7, 8 would be very similar. Just convert either from radians, degrees, or degrees to radians. Make sure you use the correct formula that I gave you. You should be good. Same thing here. I don't think there's anything else that we need to cover. Negative angle between 6 and 0. Okay. Here, this section talks about coterminal. All right. So number 15 says the angle between 0 and 360 that is coterminal to 698. So as we know, we said 698 is above a revolution. So you'd have to subtract those extra revolutions. Okay. So the only idea you really need to remember is that all of these angles here can be represented by an infinite number of angles, because I can always keep spinning around and landing here again. So I have 60 and I add 360, I end up back where I started, right? Add another 360, well, that's going to be this. Again and again. So I can keep doing that, so become 360 plus 60, what is that? 7, 4, 20, right? Then again, and then again, you can keep getting angles. So on number 15, they give us 698. Okay, so let's do this on paper. Find the coterminal angle of, they said 698. So all you gotta do, subtract 360, right? 698 minus 360, 338. So this would be a coterminal angle that is between 0 and 360. That was their requirement. So if you notice that it's already bigger than full revolution, just subtract it. You'll always get a coterminal angle. Now, if it's smaller than full revolution and you subtract, well, you're just going to get a negative, which is still a coterminal angle. So this would be, let's see here. That's wrong. Oh, they just give me a different. It's fine. Anyway, I lost my place here. That's all you got to do. Coterminal would be 330, but there is more than one answer. But because they said between 0 and 360, that forced you to have one answer. They don't specify this first one. Then yeah, you have infinite values to choose from. Okay. Here they want negative angles, so just add 360 to this and make sure it stays negative. It's not too crazy. 17. They want the smallest one that's still positive and coterminal to 1034. So here just keep subtracting 360 until you are below 360. That will be your answer here. Over here, you keep adding 360 until you get above negative 360. That's pretty much it. This is just talking about quadrants. the point P 4/5 comma y is on the unit circle, quadrant 4, then y must be second. Let me see if you want me to use four triangles. Oh, no. Okay. So in this one, you can use the formula or you could use a triangle. Doesn't matter. But I think that they want us to do the formula. So I'm going to do this number 22 right here. Okay, this is question 22. Sorry. So rewrite this again. So 4/5 comma y is on the unit circle. So what you have to remember is that all circles centered at 0 are equal to x squared plus y squared, equal to its radius. Since it's a unit circle, always be equal to 1. So this is the formula, your formula you're going to use that represents a unit circle. So we have x, and we know it's in quadrant 4, which means that y is negative. So when you solve for y using this formula, you'll have a plus or minus, you will choose the minus. Let me show you what I mean. So plug in the 4/5. Subtract that over, that's going to be 1 minus, right? Subtract this. 4/5 squared, that'll be 16 25ths. Right? So y squared equals 20, get the common denominator here, 25 over 25. 25 minus 16, that's going to be 9, right? That's y squared. So square root both sides. But whenever you square root both sides, you have to tack on the plus or minus. So y is equal to plus or minus 3/5 when you square root both parts. So you choose the minus because of the quadrant. We said that y is negative. So this will be your answer for y. So when you solve these, use the formula. Then remember the quadrant and choose the correct sign. Okay? That's all you got to do. And that's pretty much it for 5.1. If you guys have any questions, just bring them Monday. No big deal. This is the same stuff, except they have radians instead of degrees. So you find coterminals, but you can either change it to degrees and then do it, or subtract 2 pi from this, or add 2 pi. Super similar. So I'll leave those to you. All right, let's get to 5.2. All right, let's start 5.2. So this one's, I think, pretty straightforward. We'll mainly be using the unit circle that I gave you. I'm not going to force you to memorize anything. You can use that whenever you want, as I said, a separate sheet during your exams. So a unit circle has a center at 0, 0, so it's right in the middle. Ignore my horrible circle, can't draw. And radius 1. So imagine this is a circle, perfect circle going out 1. The length of the intercepted arc is equal to the radian measure of the central angle. We'll call this theta instead. Let xy be the endpoint on the unit circle of an arc length s. So the distance from here to here is s. But that's not important right this second. The xy coordinate of this point can be described as functions of the angle. So basically, cosine of this angle is actually the x point. Sine of this angle is the y point. Okay, so when you look at the unit circle, find it. if they ask you for sine of, I don't know, pi thirds, they're asking for the y value. So this is the sine. If they ask for cosine of pi thirds, and they mean this one. Okay. So let's look at our homework. And we have to remember our quadrants as well. Okay. So the first question, number 1, says, from the information given, find the quadrant in which the terminal point determined by t in point 1, 2, 3, or 4. Okay, so here they're telling us sine is negative, cosine is negative. Well, they're both negative, right? Less than 0. That has to be quadrant 3. So the easiest way to remember is think of this as your y and your x, right? So if x and y are negative, then we have to be here, right? X and y, remember I gave you the first section is positive, minus plus, minus minus, plus minus, right? So sine, cosine are both negative here, x and y are both negative here. Same thing. Okay. So now let's put both screens on. If sine is positive and cosine is negative, that means y is positive, sine is negative, or sorry, y is positive, x is negative, so it has to be 2. This is 2. They're both positive, it has to be the worst 2 ever written. It has to be 1. Y is negative and x is positive, then 4. Both negative, we said 3. So just remember what I told you before, right? It's a circle, we said plus plus, negative plus, minus minus. So this is in your notes, right? Plus minus. Okay, so that's for quadrants. So very similar to what we did before. Now, cosine of negative pi over 6. Remember, negative means go clockwise. Let's look at the circle. Positive pi over 6 would be right here, right? Negative pi over 6 would be right there. Same distance as negative direction. So what is the x value, right? Cosine is asking what is, basically when you see cosine of an angle, they're asking what is your x value? It's this one. So it would be square root of 3, 2. Okay. That's it. Next one, number 3. Cosine pi 4/3. So that's positive. So we go clockwise. 4 pi thirds. That's going to be right here. So positive direction right there. Cosine is asking for x. So you would just write negative half. Cosine pi, well, it's right here. That's negative 1. X value. That's it. So you just keep looking at the circle. Sine of 11 pi 6. Okay. 11 pi 6 is right here. The y value sine is this one. So you would write negative 1/2 as your answer. Okay, so same thing here. Let's see. Only thing I need to mention here is notice if they say exact, do not use your calculator. They want to see square root something or 1/2. Okay. Over here it says evaluate, it doesn't say exact. These are not on the circle, so you're gonna have to use your calculator. Just make sure that your calculator is in radians to punch this in. Okay. So go to mode and change it depending on your calculator. Find the exact, use your circle, y value, x value, y value, x value. Same deal. Nothing crazy. Now, if you get an angle that's large, these are, I think, bigger than 2 pi, right? Because 2 pi is the same as. Watch that as your calculator. 3.14 times 2. It's like about 6.3 something. Let's just do 3.14 times 2. So this is about 6.2. 7 pi thirds, if you multiply that out, 7 times pi divided by 3. This right here is about 7.33. So clearly this is more than 360, right? More than 2 pi. So just subtract. So what you would do, right, is take 7 pi thirds. Since we know it's bigger than this whole circle, just like the last section, we subtract 360. Same thing, subtract 2 pi. And then the answer that you get, you should be on the circle. Okay. Now, if you don't like doing the fraction stuff and you hate the radians, you can always convert this to degrees and then subtract 360 instead. Up to you. It's the same thing as just different units, I guess. But anyway, either way, it's the exact same thing as before. You're just looking at the y value. You just need to do an extra step. Find coterminal angles that are on the circle, so it's easier to deal with. Okay. Just keep pay attention to exact. If it says exact, you have to use the circle. If it doesn't, get away with a decimal. Problem. Here, obviously bigger than 360, so subtract a few 360s until you get to something below 360. So you would just take the 1290 minus 360 over and over again on your calculator. Just keep pressing minus 360, minus 360. Right. 1290. If I were to do this on my calculator, my phone, right? You just do minus 360, minus 360, minus 360. Eventually, I'm below 360, so this is a coterminal. So do sine of 210, right? So go back to this guy here. 210 is right here, right? So sine of 210 is the same as sine of 1290. So just write this value. These are 210 is coterminal to 1290. So you use this. It's the same type of stuff. Right. But that's pretty much it. Let's see here. Here, they're asking the same question, but they're not mentioning sine. They're saying, give me the x and y, but we know that x is the cosine, right? Cosine of whatever angle they're talking about. In this case, it's going to be alpha. Y is technically sine alpha. So just plug this alpha to here, right? Or go in your circle and say, okay, well, pi over 2 sine is the y value, it's a 1, so this would be a 1. Cosine of x, or I'm sorry, cosine of pi over 2 is the x, so 0, so that would be 0. That's it. And just keep in mind that if it's a negative angle, you go this way. So negative pi over 2 is the same as 3 pi over 2 for part B. So just get comfortable with negative and positive and go in the correct direction. And it should be pretty simple. That's pretty much it. Reference, that's something we have not talked about. So a reference angle is basically the distance from the x-axis to this angle they're talking about. So whenever I have a question, just figure out, okay, well, how far am I from the x-axis, right? Let's do the degrees because it's easier to see in your head. Okay. So 260 and make sure both things are there. 260 is somewhere around right there. So you agree that 260 is right there, right? Obviously. So it'd be all the way to here. Okay. So there's my 260. So how far is it to there? Right? How far is it from here to the x-axis? That's basically what they're asking, like how many angles. So what you can do, if I'm at 260, just subtract 180. You'll get that piece here, right? So paper, and then we'll do that example. Reference angle. Let me find the proper definition. Even though it's straightforward, we should write down the proper. Okay. Reference angle definition. There we go. Let me show you the page. This is in your book. Okay. That'll be easier just to see how you do it, right? So this is the part you're gonna need. Given an angle between 0 and 2 pi, find its reference angle. So an angle in the first quadrant is its own reference, right? Which makes sense. Because if I go here to here, that's going to be like 60, right? How far is that from the x? Well, obviously, I just said it, 60. If I go from here to here, well, now we got to figure, okay, well, how far is it from here? The closest distance to the x? I'm going to have to subtract 180 minus the angle. So if you're in quadrant 2, just do 180 minus whatever angle is in question, okay? Or pi, same thing. If you're in quadrant 3, you do the angle minus 180. So 200 and in our question, right? We had 270 or something. Our question is 260 is quadrant 3. So you would do next book 260 minus 180. That'll be your answer. If you're in quadrant 4, you do 360 minus the angle they're asking. So I would recommend putting this page 180, 584. Just write this down in your notes. You're like a formula card. Or a formula page. Put that on your formula page. Okay. Let me see if I can send it to you later. Maybe I can screenshot it. So don't worry about it later. Okay. So go back to our question. Okay. So 260. Example 1 for reference angles. Reference angle for 260 degrees is simply, and we said the rule, right? Rule is 260 minus 180. So if you do 260 degrees minus 180, that'll be your answer. That would be 80 degrees, right? Example 2. Go back. Question says, $282. Well, that's now in quadrant 4. So you would say, okay, reference angle for 282 degrees. That would be 360 degrees minus 282. That's the rule for being a quadrant, right? Right here. Minus 282. That would be 78 degrees. So this is my reference angle. And so just follow those rules. So if they ask for reference, you don't have to memorize that. It's just a procedure. That's pretty much it for fun 5.2. So can you use the unit circle, right? Can you tell what quadrant the angles are in? And can you find reference angles? That's it.